This is appropriate for higher tier students, predominantly Key Stage 4, and it will cover simplifying surds, expanding brackets with surds, and rationalizing the denominator, so a fraction with surds. Okay. Now, firstly, what are surds? Surds are a way of writing square roots of numbers that are not square numbers. So, in simple terms, if I wrote root 64, you should all know that the answer to that is 8. Technically, it's plus or minus 8, but 8 is the answer, right? Now, if I wrote root, I don't know, 7, 7 is not a square number. So what you do is you'd leave it as a surd. Okay. Now, sometimes on your calculator, if you're doing like a Pythagoras question, and you end up with the square root of something that isn't a square number, like 13, it will just come up as a surd. Now, what you normally do automatically is you press this button SD, turn it into a decimal, and that's what you write. But this number here is a surd. So you have seen surds before, you just don't really think of them too much because you just automatically may say, oh, it's a decimal. All right? But that is a surd there, root 13, for example. So let's start with the basics then, which is simplifying surds. So looking at question 1, write root 48 in the form k root 3, where k is an integer. So the way to simplify surds is you need to find a square number that divides into 48. So in this case, I'm thinking of something times, well, I know it's going to be something times 3, which makes 48. So I'd say the easiest way to do this is to just divide 48 by 3. Or, if you prefer, be thinking about numbers that are square numbers. So 4, 9, 16, 25, for example. So these are the first few square numbers. Now, which of these divides nicely into 48? 4 does. 4 goes into 48 12 times. 9 doesn't. 16 does. 16 goes into 48 3 times. 25 doesn't, and after that, well, none of the rest do. So basically, 16 and 4 go into it. Now, what you really want to do is pick the bigger one, so 16. And in this case, because I know that the other number's 3, basically it's 16 times 3 makes 48. So I can rewrite this as root 16 times root 3. Okay? So the square root of 16 then is 4. So I'm going to write this as 4 times root 3. And just like with algebra, when you write a multiply between two terms, you can just write them next to each other. So that is the same as me saying 4 root 3. Just like you'd write, I don't know, 4 times x is 4x, 4 times root 3 is 4 root 3. And that now looks like it's meant to. That looks like that. So basically k is 4. My answer is 4 root 3. Okay, so let's move on then to a slightly different question where you're expanding a bracket or you're multiplying with surds. So we're looking at question 5 now. Now, expanding a bracket, you'll all know using this method FOIL. First, outside, inside, last. So let's do that. Let's just let this focus. Apologies. Right, so 2 times 2 is 4. 2 times minus root 3 is minus 2 root 3. Root 3 times 2 is plus 2 root 3. And root 3 times minus root 3, that's the last, will be minus, well, root 3 times root 3 is the same as root 9. So the square root of 9 is 3. So what I'm going to end up with here is 4. These two things cancel each other out. If you think about it, you've got minus 2 root 3 plus 2 root 3, so that cancels itself out. And the square root of 9 is 3, so basically 4 take away 3. Our answer then is 1. So the answer to this question is 1. See if you can try sort of question 6, question 7, question 8 yourselves. I'll give you a chance to do that now. You can pause the video and have a go at question 6. So question 6, when you're squaring a bracket, that's 3 root 5. That's what you've got. You've got the bracket multiplied by itself, and once again we're going to use FOIL. So here we go. 3 times 3 is 9. 3 times root 5 is plus 3 root 5. Root 5 times 3 is plus another 3 root 5. You can write them in whatever order you like, but as you do with algebra, you write the number before the algebraic term. So 3x. X times 3 is 3x. Root 5 times 3 is 3 root 5. That's what I'm trying to say. And then finally, root 5 times root 5. Well, that is the square root of 25, which is 5. So 9 plus 3 root 5 plus another 3 root 5. Imagine it was 3x plus 3x. That's 6x. So 3 root 5 plus 3 root 5 is 6 root 5. Apologies for the x there. And then root 25 is 5. So 9 add 5. The last bit is you can collect these terms together, which gives me 14 plus 6 root 5. And that now looks the way that it wanted, the question wanted me to make it look. Something add something root 5. So 14 add 6 root 5. Okay, finally we'll look at rationalizing denominators. So we'll go in with maybe question 12 looks pretty good. So I'm just going to zoom in a little bit on that one. Question 12 here says, rationalize the denominator of 1 plus root 5 over root 2. Now, rational is it's a type of number. So mathematicians talk about rational and irrational numbers. A surd is an irrational number. Okay, irrational. Effectively meaning that it's a decimal that goes on for ever and ever. That is what an irrational number is. So to rationalize this, I am going to or rationalize the denominator anyway, which is just this bit. I'm going to multiply it by something, and what I'm going to multiply it by is the surd over itself, because whenever I times something by something over itself, this is the same as 1. Anything divided by itself is 1. So when I'm timesing something by 1, I don't change it at all. Alright, that's effectively what I'm doing. I'm timesing it by 1. Now when I do that, what I've got here is effectively a bracket. I've got 1 plus root 5, and on the bottom I've got root 2 times root 2, which is root 4, which is therefore 2. So at the bottom, it's just going to end up being 2. At the top, though, you've got this bracket to expand. So root 2 times 1 is root 2. Root 2 times root 5 is root 10. Now, some of you will look at that and think, oh, can I collect those two together? Now, you're not allowed to do that. Just like with algebra, if you consider that these are two different terms, so that's like x and y, when you're adding x add y, you can't put it together and write xy. You're allowed to do that when you're multiplying, but not when you're adding. So in this case, that is the answer. Root 2 plus root 10 over 2. Now we'll do one final question, one of the harder style questions, where we'll rationalize something that's a little bit more complicated looking. Ooh, which one do I like the look of? There's a few here which look interesting. That one looks good. So let's look at question 15 then. Question 15. So in this case, I've got 2 plus root 3 at the bottom, and it's asking me to show that I can write this like this. So, the way we're going to do this is we are going to multiply it like we did before by something over itself, because remember, when you divide anything by itself, it's the same as 1. So, timesing something by 1 doesn't change the value. So, you're allowed to times this by something over itself. The question is, what am I going to times it by? Because if I times it by 2 plus root 3, then at the bottom, I'm not actually going to cancel out my surd. Here's what I mean by that. So if I did 2 plus root 3 and I times that by 2 plus root 3, here's what you'll end up with. You'll end up with 4 plus 2 root 3 plus another 2 root 3 plus the square root of 9, which is 3. So, and when I collect those terms together, you end up with 7 plus 4 root 3. So I haven't gotten rid of the surd. So basically, you don't want to do that. You don't times it by the denominator again, what you actually want to do is change this sign. So here's what I mean. I'm just going to rewrite the question. 5, because I've run out of space at the top there. 5 plus 2 root 3 over 2 plus root 3. And I'm going to times it by something over itself. And it's the denominator, but I'm going to change the sign in front of the surd. So it's 2 minus root 3 over 2 minus root 3. Now once again, just to remind you, if I divide something by itself, that's the same as 1. So, 100 divided by 100 is 1. 2 minus root 3 divided by 2 minus root 3 is 1. So when I'm timesing by 1, I'm not changing the value of my surd whatsoever. However, it will look different. So now you're expanding a double bracket. Okay, so remember timesing fractions straight across, yeah? So this numerator times this numerator. This denominator times this denominator. Let's do it then. So I'm going to do the top first, and I'm going to use FOIL. FOIL is one of those methods that really works every time with multiplying brackets. So 5 times 2 is 10. 5 times minus root 3 is minus 5 root 3. 2 root 3 times 2 is plus 4 root 3. That's 2 times 2, basically 4, and root 3 times nothing there, so root 3. And finally, 2 root 3 times minus root 3, that's going to be minus 2 root 9. Okay? Now, 2 root 9 is 3, so 2 times 3 that is, which is going to end up being 6. I'll just write that there to remind us later. Now, at the bottom, remember the aim here is to get rid of this surd, and hopefully that's going to happen now. 2 times 2, so first 2 times 2, which is 4. 2 times minus root 3, which is minus 2 root 3. Root 3 times 2, which is plus 2 root 3. And root 3 times minus root 3, which is minus root 9. Now you'll notice, year 11, you'll notice, students, that this is minus 2 root 3 and plus 2 root 3 cancel each other out. So I am getting rid of the surd at the bottom. I know it looks like there's a surd still there, but that's a square number, so that's actually 3. Square root of 9 is 3. So I'm going to simplify the top. 10, take away 6, remember, so that's going to be 4. Minus 5 root 3 plus 4 root 3 is minus 1 root 3. Now when it's 1 root 3, you can just write root 3, but that's the top. And on the bottom, 4 take away the square root of 9 is 3. 4 take away 3 is 1. Now, dividing something by 1 just leaves it the same, leaves it as it is. 100 divided by 1 is 100. 50 divided by 1 is 50. So that is 4 minus root 3, which is what they wanted me to show. I've just shown that I can rewrite this as 4 minus root 3. There it is. Okay? See if you can have a go at the question below then. I'll remind you then, the first step here is you're going to times it by something, and you're going to times it by the denominator, but you're going to change that sign. So you're going to basically do this over this times by that over itself. And when you expand these two brackets out, so do all of these timesings, all these multiplications, when you times all that out, you should end up simplifying to just root 3. Have a go at that.